Welcome back, everybody. Today we're going to talk about different pairs of angles. When talking about two pairs of angles in geometry, I'm just going to show you a few examples. First pair we're going to talk about, these right here. These are known as vertical angles. Vertical angles are completely opposite of each other. So angle A and angle B here are vertical angles. And the thing to know about vertical angles is they are equal in measure. Okay, next up we could also have a couple angles that sort of look like this. Talking about angles C and D. Angles C and D are what we call adjacent angles. Adjacent angles are right next to each other. They share a side, like this side right here. Alright, the last two pairs of angles we're going to talk about, complementary. I have a big word to spell here, and also supplementary. Alright, complementary. Here's a couple of complementary angles, approximately, not drawn to scale, mind you. A couple that look like that. The thing about complementary angles is they add up to 90. So let's say this angle was 30 degrees and this angle was 60 degrees. We would say they're complementary because they add up to 90. These two angles here, again, not drawn to scale, we could say they are supplementary. When you see supplementary, think 180. Let's say this angle is 140 and this angle is 40. Notice how they add up to 180. That makes them supplementary. And then there's another pair of angles that I want to mention because they tie into a couple of these, known as a linear pair. A linear pair is formed from one straight line. Could look like this. And let's say one angle could be 70 and say this angle would be 110. Linear pairs are always also supplementary, but just notice how they're formed from the same line. We have one line coming off and then we have these two angles. Let's look at a couple here. Angles 1 and 2 are complementary. 1 is 49. What is the measure of angle 2? Well, if they're complementary, they add up to 90. So we have an unknown angle, which is angle 2, angle 1, and if I add them together, they get 40. They get equal to 90. So in order to solve this, we could subtract 49 from both sides. And the missing angle is 41. So we could say it like this: the measure of angle 2 equals 41 degrees. Let's look at another one. In this image here, we have several intersecting lines. Make 90 degrees here, but really we just need to focus on this right here. And we're looking at sort of all three of these angles here. The fact that this angle is 90 will also imply that this angle is 90 due to the vertical angles. They're vertical angles. And if we were to add up all three of those angle measures, given that this one is 90 degrees, 61 plus 90 plus x would equal 180. And that equation would help us solve for the missing angle if we were to find that. That would be choice B here. X plus 90 plus 61 equals 180. We can certainly find that if you wanted to by taking 180, subtracting 90, and then also subtracting 61. We get 29. If they wanted to ask for what x was, you would find it to be x is 29 degrees. Notice the drawing is not drawn to scale. Let's look at another one here. Kind of a similar situation. You got three angles from here to here. All of them add up to 180 degrees. but we got to find the equation that would help us solve for x. Looking at all the choices here, it turns out that choice B would be the winning choice, because in order to solve this for x, we'd have to subtract away the 53 and the 37. We could in fact add them together first, as they're showing here, sort of a distributive property. We could distribute that negative sign if we wanted to and have minus 37 minus 53, but we get the same result no matter what. And if we were to plug that in a calculator, we would get 90. The missing angle would be 90 degrees. Looking at this one, what is the value of x in the figure? Well, if you notice, we have two angles that are on the other side of a 90 degree, therefore they also must add up to 90. You could say x plus 61 equals 90. We could take away 61 from both sides, and x would equal 29. So then that is our missing angle measure, 29 degrees. Remember, complementary, they have to add up to 90 degrees. That's how we can use that information to solve this problem. Last one, angles 1 and 2 are vertical. So a vertical situation like this, we could say this is angle 1, this is angle 2. They tell us angle 2 is 93 degrees. And the thing about vertical angles is, if they are vertical angles, they are opposite of each other. They're also equal in measure here. These two are equal in measure. So we could say it like this. The measure of angle 1 is also 93 degrees, just like angle 2. There we go. I hope that helps your understanding of different types of linear pairs of angles, the linear pair, verticals, complementary, supplementary, and adjacent. Thanks for watching.